Okay, any questions so far? Let me handle the question first. Any questions so far? No? No question? Okay, we'll get started, okay? Last week, we talked about the tokenization, okay? Basically, tokenization is because that you have a file, you have the source code, say, .python or any language file, right? So you actually go through tokenization. So the output of the tokenization would be tokens, okay? Okay, it will be tokens, okay? It will be created into tokens. And last week, actually, we are using the so-called ad hoc, okay? So hardwire, you actually do hard coding just using the state machine and then coding for the tokenizer, okay? That's what we actually do last week, okay? So this week, we are talking about scanner design, okay? It actually lecture 11 is scanner design. So this scanner design is using systematic way of designing the tokenizer, okay? So it's actually put into a systematic way to do it, okay? So the goal for this one is that you understand what is compiler, okay? What is compiler? It's a compiler to generate compiler, okay? We call it compiler. So we'll be introducing LAX, EX, REST, and Bison, and PRE, okay? PRE. What are these? This one, first one, LAX and EX. LAX and EX is the original lexical analysis and a parser for compiler, okay? And EX is called yet another compiler, okay? So the names like that. LAX is lexical analyzer. And then we have this PC version, Windows version called Flex and Bison. Okay, so Flex is the less version on Windows. Bison is the yet version on Windows. Okay, and last one is called PRE. PRE software is the Python lexical analyzer and yet another compiler. So basically, it's called Python, LAX, and yet another compiler, YEC, okay? So basically, it's called PLY, okay? PLY, okay? So that's why we are going to introduce, okay? This one is actually systematic way of generating the compiler, okay? So first, you need to learn about regular expression and the content-free grammar. Regular expression will be used to fit into LAX and complex, and this is this lecture. Okay, so the next few lecture we may talk about content-free grammar and fit into the YEC. Okay, so we'll study the lexical analysis using regular expression. Okay, and then we'll be using the simple scanner design. Okay, to generate the tokens. So here we are using the software to generate a compiler now. It's different from the previous chapter, the previous lecture. Previous lecture is we are based on hardwired compiler, lexical analyzer. We do coding by handcrafting, okay? That's last week. So overview for LAX and YEC, okay? So basically in 1975, writing a compiler is a wasting times process, okay, time-consuming process. So two-person L, this Lesk and Johnson published paper on LAX and EX. So they try to generate a compiler, okay? And then Flex and Bison are cloned for LAX and EX, obtained by GNU and CYG Win. Okay, I think this one is also GNU copy of the Windows version. And then it's a 32-bit Windows port for GNU software. Okay, so basically have been ported to the MinGW. MinGW is a minimum whatever. I think it's a minimum version of the GNU Windows environment. Okay, MinGW means that. So it is a Windows version of the software mimic the GNU software on the Linux. Okay, on the Linux. So this is actually usually the Flex and Python work on the MinGW environment. So in a way, you need to install the 32-bit or 64-bit MinGW on your PC or your Windows before you can run Flex and Python. So the idea is that, okay, you write the regular expression and then you feed into the lexical analyzer next program, and then this program will generate a lexical analyzer. So some sort of that C or C double plus program will be generated, and you can include C language. Okay, it will be actually be included into the your main program. Okay, and your content-free grammar will be used to generate that C program for the syntax analyzer for parsing. Okay, so basically by doing this, you are able to generate a compiler. Okay, so basically that's the idea. Okay, so first thing is like we need to know about the regular expression is .l file. You need to write a lot of code in .l file to actually the .l file is a lexical file input for the next, okay, or Flex, and you can run it and generate the lexical analyzer. Okay, so that actually something like that. Okay, and syntax analysis or semantic analysis, you are generating a .y file, ex file, and then it is in content-free grammar format, and then feed into the ex program, and you generate a syntax analyzer, okay, to build a syntax tree, something like that. So anyway, these are the first step. So basically, you use a calculator.y. So that's assume the calculator is a language. You feed into Python, you will create a table. And then you will also create a table.h file. That's a C type.h file for you to include. And then you use your .al file to generate lex.yy.c. That actually is a C program that you can use to create your lexical analyzer. Okay, and then these two in combination, you actually compile together to create a calculator, compiler, or interpreter, depending on your main program. You can actually include your own main program as well. Okay, and then you actually could create a simulator, assembly simulator, or create an interpreter, or create a executable program that is your compiler. Based on what? Based on your code generation stage. Your code generation stage, you can use a virtual machine to directly run it or generate the assembly code. So later you can do assembly or directly generating the executable code for the compiler. Okay, so the last stage code generation can make a difference there. Okay, so that's the flow. Okay, so basically that's the flow that you need to create. So you need to do Python -d calculator.y, press, release, and then combination to run it. Okay, and basically this one is heavily dependent on C language. Okay, heavily dependent, and there are some reference material. So let's look at the first part. Let's look at the next theory. Okay, so during the first phase, the compiler read the input and convert the string from source to token. Okay, that's the first thing we want to do. Okay, and it's using next. Okay, and then let's see. And then next theory is like, okay, you need to know about later. Okay, your ID. Okay, your ID can be have a leading letter followed by letter or digit, and this one is 0 or more. Okay, the star means 0 or more. This is regular expression representation. So this one is a regular expression for an ID. An ID means that you are available. So basically, you declare integer a equals 3. This a is at least a leading letter followed by letter and digit. Okay. So if we actually draw it in the syntax diagram, this one should be a letter followed by a letter or digit. Okay, something like that. So this one we call it syntax diagram. Okay, sometimes called SSD. Okay, syntax diagram or SD. So before you generate the regular expression, you may want to write the syntax diagram first, and then convert it to the regular expression format that is acceptable to the next. Okay, so basic star is for repetition. Okay, vertical bar is for alternation, that actually OR operation. So it's letter or digit. Okay, letter or digit. And OR is represented in separate parts in the syntax diagram. Okay, so this one repeat can be one time, can be multiple times. And this format is to write the so-called star, because you can come here one time or no times. Okay. So basically that is the representation for that. Okay. Okay. And then let's go back. So that's a simple definition for the next, okay, for the regular expression. So there's a repetition, alternation, and concatenation. Concatenation means here you have letter followed by this. Okay, followed by this is concatenation. So the string will connect it together. Okay, after that. And repetition is on here, the star. Okay, alternation is the vertical bar. Okay, this one is the basic notation by the regular expression. Okay. So your finite state machine, you can represent it like this. Okay, so a finite state machine can be translated to the so-called syntax diagram and then be translated to regular expression. So regular expression and syntax diagram and finite state machine is a 3-in-1. All three are equivalent. If you write in one way, say syntax diagram, it can be converted to your finite state machine diagram. It can also be converted to the regular expression without any problem. Okay, so these three are the same thing, and you can write the analyzer by hard coding. Hard coding here we have the algorithm for hard coding such a finite state machine into program code. Okay, so you can do conversion of it using to write an AHAP analyzer by converting the finite state machine into program. That's not a problem. Okay, I think you guys can do it. Not really hard. Okay, so but next program would really like to have the regular expression. Okay, so regular expression in Flex is composed of some meta characters. Okay, so it actually has some meta characters. So the later being used in the next language is if you have a dot, it means any character except the new line. So dot is any later. Wildcard, this one we call it wildcard. So if you have any later, you use a dot, that means dot. Okay. \n, I think everybody knows it's a new line mark. And then star is 0 for more. 1 is 1 or more. Okay. Question mark is actually 0 or 1 copy. Okay. So these are quantifiers describing how many times it will happen. So this one is 0 or more. This plus sign is 1 or more. Question mark is 0 or 1. Okay. And then cat is the beginning of the line. Dollar sign is ending of the line. Okay. These are the standard meta symbol for the next language. And then vertical bar is all. Okay. And then grouping using parentheses, that's a grouping. Plus sign actually is 1 or more copy. That's the quantifier that we describe here, but parentheses is for grouping. Okay. Plus is concatenation. And character set, this one is working for set. So if you say A to G, that's all the data from A to G. Okay. And we'll talk about this more later. So these are the basic language that you use for regular expression. And then ABC means ABC. ABC star means AB followed by C 0 or more time. So it will become AB, ABC, ABCC, ABCCC. Okay. Because C will be 0 or more time. Plus sign, it will be ABC at least 1 time. So 1 or more is actually ABC, ABCC, ABCCC, ABCCC. Okay. This is this. This one is A followed by BC 1 or more times. It's ABC, ABC, BC, ABC, BC, BC. Okay, this is like that. ABC, BC 0 or 1 time. So it's A followed or ABC. These are the regular expression. ABC in a set is one of the A or B or C. So this one equivalent to A or B or C. Okay, like that. A to G means all the lowercase letters. Okay, A to G capital case letters. Okay, and then minus AG means that all letters except for A and G. This one is when you have a vertical, when you have a bar means just include A and G. I'm sorry. This minus sign right now actually is minus A or D. So three, any one of these. Okay. There's an include one. Okay, we'll see later. So here you have A to G, lowercase A to D, and 0 to 9. This one was one of the data of the digit. Okay, and then this one space /T /N. That's white space letters. Okay, I'm sorry. When the except one is using cap. Okay, so this one I explained it wrong in it here. Okay, this one is minus sign with a and the A and D. This one, when you have a cap, that means that any letter except for A and B. Okay, that's inclusive. Okay, inclusive. So it's inclusive. And this one means A cap or B. This is different. Your first one's cap means every possible letters, but not A and B. Okay, excepting the A and B. And then A or B is vertical bar. So this one is actually vertical bar or A or B. Okay, and outside means A or B. So these actually two are different. Okay, so two. Okay, anyway, you need to study the regular expression and then knowing how to use it. But usually we don't design the grammar by regular expression. We design it by the syntax diagram first. Okay, I'll show you how to do it later. Okay, and then you will generate a function int YYDEX. Okay, that's actually a YY that invoke laser, you return tokens. So this function will keep returning tokens. And there's a character called YYText that actually is a pointer to a matched string. So you do search for expression, and then it will return you a string that is matching that vector expression pattern. And then there's a YY length, means the length of the message string. YYL value is the value associated with the token. YY wrap that actually return 1 is down, 0 is not down. This one's a graybar function. And YY input file, YY out is output file for YY. Okay, so these are some, when you use a C language, the return program will have these different function and parameters for you. Okay. Okay, so here we go to look at the Flex program structure. It has definition, rule, and user program, 3 parts. So your main program is here. Your rule is in the middle. The front part is the definition, and 3 sections separated by percentage. Okay, these are very ancient tools, so their grammar is written in very simple way. Okay, so let's look at the simplest possible program. So here the Flex 0.L, it is /n and dot, and then do nothing. Okay, so this one basically you may have a program, no definition, and then every letter you will echo, change line your echoes. What do this really mean? Means that you have a program, and then every letter you just print it, and every change line you just print it. So basically this one, you just read in the file. If you have a lexical analyzer, you just read in the file, and every letter will be just be printed out. So you create a function like that. And this one is your main program being included, and YY return 1 will be included. Okay, so this program basically just echo the input. Okay, so let's look at this one now. Okay, let me actually go to the program. So basically here I have a Flex and Python, and I have a C development. So let's look at Flex 0. Okay, I'm trying to. So here I do have a Flex 0 and next.yy.c. So let's look at it. So whenever you want to bring up your Windows, you do Window R, okay, and CMD bring up the command line, CMD, okay. And then you need to change to this directory. So let's change to this directory. So CD. Okay. Come to here, left click, copy. Okay. Copy to here, right click. You will change directory to there. So here, let me use the code that, okay. I'm bringing up the editor. Visual Studio Code editor, okay. And this one, remember that I'm also using it for Python, okay. So basically, it's the same. So here we do have a program called Flex 0. So Flex 0.L is actually just echoing these two, and a C language program will be generated. So when it generated, it will be something like this, okay? The program is something like this when it's generated. So when you want to run it, you run Flex, and your grammar that you actually want to fit in is Flex 0. So you run Flex 0.L. Okay, Flex is the program that actually we call it Lex. Okay, so doing this, we have a program that's called Flex 0.L. that actually is in regular expression format, but written in the Lex format. Okay, and then we pass through the Flex, and Flex will generate this lex.yy.c file. So this one is a C program. Okay, that's the what will happen. Okay, so here let's actually run this one. Wait. It got it wrong. Let me see. Let me see what happened. Okay, actually, let me see. Something wrong. Okay, let me actually break it. Okay. Let me try one more time. Okay. My computer maybe it's too slow. Okay, it's actually done. So this one will get this. That's actually, let me show you in detail. Okay. Wait, I'm sorry. Show you in detail. So basically this program, as you can see right here, the time it generated is March 2023, right? So it's just right now just created by me a moment ago. So let's use this one to look at it. Okay, so basically the program just been generated here. Okay, this one is the newer version. Okay, and then this is one program. So you need to compile it by C language. Okay, this is your main program and you compile by your C language, or you, because right here you don't have the main program. In the Flash.0, we don't specify the main program. So this one just come in with variables. These are some variables you can use. Okay, some YY input file, YY buffer size. Okay, these are some variable and function that you can use. It's a module, but at this moment there is no main program because our Flash.0 has no main program. So this one just like that. Okay, that's actually work on the Flash1. So Flash1 is here. There's a lecture being generated in Flash1. Okay, this one's different. So let's change directory to Flash1 directory. So the Flash1 is pretty simple, just showing you, Flash0 is pretty simple, just showing you that a basic compilation should be, okay. Flash1, we are different. So Flash1, this one, we do have the echo, okay, and the wrap and main function being put over here, okay. So 3 section, percentage means a separator, okay. So this one is like that. We will generate a lexyy.c file, okay. That's generated, but this one is older version, okay. So that's actually, close this one. Okay, keep this one here, okay? So let's actually go back to our C list directory. So let's change it directly to Flash1 now. Okay, in Flash1, let's run the Flash function. So Flash function, and then you run Flash1.l. Okay, it's a lexical analyzer program. So it's a regular expression program, and then we finish it. So right now, this one, lex.yy become March 2023. Okay, this is actually a new program. So right here, I'm going to do GNU GCC, that the compiler I have. Okay, and then -c, okay, lex.yy.c-o, okay, lexer 2. I don't want to override my lexer 1 that's generated before, okay. So lexer 2, so lexer 2, I'm sorry, I actually generated lexer 2. So right now, there's a lesson 2 program. I'm sorry. So let me do it one more time. So GCC-G YY-C-O lesson 2.exe. Let me create some exe file. So lesson 2 being generated. Okay. Lesson 2 being generated, and then let's try something. We want to test the program of lesson 2. So lesson 2, I pick data from on, okay, and then create it to a dot out, a dot text. Okay, let's do this. So create it from con. Oh, lesson 2 is now compatible with the Windows version. Let me try the Lexer, okay, the older version. So Lexer convert it from com and generate to a text. So here I'm typing, I am a good student, and then finish with Control D. Now finish the console input, okay, and then the file called a.text is generated. It just echo, I'm a good student. Is that okay? Every letter in will be echoed, because the rule that we specify in here is that every letter that actually input will be echoed. Change line mark will also be echoed. Okay. So I actually generate a file from console and then output it to a.text. Okay. So you pass it. So this one is how a simple program being generated for you. Let's look at a small complicated one. So phrase number 2. Okay. So let's look at this one. So let's do CD up, CD phrase 2. Okay. Let's look at this one. File, open folder, and press 2. Okay, let's look at this one. Change the folder to here. So let's do this one is a little bit more complicated. First one, it actually still have 3 sections. Okay, 3 sections. So 3 sections is section 1 definition, section 2 the rule. Okay, section 3 main program. Okay, so still like that. So section 1 is say define a variable called YY line number. So you will have a line number being created. Okay, line number being created. So this one will be available that later your main program can use. Okay, so anyway, when we generate the YY.C, there is a YY line number it will be generated in the that's the YY.C. Okay. Anyway, here you do see cap is a starting of the string, and you have any letter 0 or more with a change line. So this one is actually every line, okay, every character followed by a change line. You print 4 digits with the YY line number. So YY line number will be put into this printf function, and then the YY text is your match text. Your match text will be here. So basically, it will be a 4-digit line number followed by a 10, followed by YY text. Okay, followed by YY text, and then that's the rule. Every letter coming in will be generated. So your main program would have ARGC and ARGCV. Okay, this is typical way of writing C program. So you open file with your ARGV1 for reading. So basically your main program say your press 2, and then you say a.text. Then this is the ARGV1. This is the string. You open this one and you do YYLS. So everyone will follow this one to generate the tokens, and then you will close the file later. Okay, so this one pretty simple. Every single line will be followed by a a program. So here, I don't know why my Windows no longer be able to compile because newer version, I think Windows 10 may not support a Flash. But anyway, we already have the Flash 2. Okay, let's look at YY.C. This YY.C right now, that's actually fine for YY line number. Okay, so it has a new YY line number being generated. Is in Flash 2.y. Okay. Okay, and then that's the main program. So you compile this one, you will get Flash 2.exe. So right here, let's do Flash 2.e program that still generate from console that actually still generated output to text. So from console, let's do this one. I am a good student. I go to Louis University. I am studying computer science. Okay, control Z, that we have 3 lines, and then finish the console for file. So that text being generated, and here you see the line number being generated before it. Okay, because we put the YY line number in our regular expression, YY line number. Every time you print the YY line number first, followed by tab, followed by the message string. The message string is a line. Any 0 or more later, followed by change line mark, you'll be printed as a YY text. Is that okay? This is how it works. Okay, but bottom line is you must know about C language. If you don't know about C language, you cannot operate this tool. Okay. Anyway, that's the systematical. So why Flash 2 is like that? Let's look at Flash 3. This one is actually a series of material that I created to teach students for the lesson Python. Okay, so let's look at Flash 3. So Flash 3 will be more complicated than Flash 2. So this one, there's an integer count, and then A to D. You count the number of characters whenever you have A to D, okay, any of the, I'm sorry, this one actually is one ID. If there is an ID, okay, you would increase the counter. Every character, you do nothing. So here you read number of identifiers and you count. Okay, so that's the purpose of this one. Let's look at the result directly. Okay, so this is YY Flash 3. So CD up, CD Flash 3. So let's try this. Okay, in here, let's create a new file. This one, let's call it Python1.py. Okay, so A equals 1, 2, 3. Okay, and then print A. Okay, and then actually stored A. Okay, whatever. Okay, this one. Okay, just do this. Okay. Okay, whatever. Okay. Okay, let's do this. Okay. So this one, whatever we actually create a program, it may be legal, maybe not legal. I don't care. Okay, but this one is the program we are going to feed into Flash 3. Okay. So this is the program we are going to feed into Flash 3. So Flash 3, okay, coming from the Python1.py, okay. So that's actually we fill it in. And then every time you print F, okay, the print F. So that's actually also redirect the file to A.text. Okay. And then we would have the result in A.text. So number of identifier is 6. Let's go back to look at the program. There are 6 ID, okay. So let's look at our Python here, okay. So here we do have 1 ID, 2 ID, 3 ID, 4 ID, 5 ID, 6 ID. Is that okay? Make sense? Is that okay? We do.
Oh, because you're tokenizing or
tokenizing this Python.py, yes. And using the grammar rule here is a ID. This is the ID. Whenever the ID my counter increase. So this is a variable defined in here. Okay. Any question?
I actually do have a quick question about how this all works. Is that, let's say I use like a Python library, would this be able to tokenize the library or no?
Python, yes. Well, it doesn't go through the library. It actually just pass in every program you have.
Okay.
Library, I think just token import. Import is a ID or something like that. Is that okay?
Yeah, that's okay. Thank you.
So the right here, what I want to say is that grammar portion will become more complicated every time when we try different program. And to a certain version, it will be a real world tokenizer. Okay, is that okay?
it looks like the brackets are a range of characters you want to single out. Every time you see brackets.
Brackets are, the left-hand side is the pattern, right-hand side is the program generated. If you look at the rule here, yes, what you say is, let's go back to the 3. It's a result that you generated, okay? Left-hand side is your pattern, your ID pattern. Right-hand side is your C program that generated to your main program. Is that okay? This one is just do counter increase.
Counting the tokens.
Yeah, counting the tokens. And this one, any other letters, just pass. Don't care.
Oh, okay. I didn't see that one.
Semicolon. Okay. So basically, your program you try to catch here. It means when you do tokenization, is actually token. Don't care. 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 Token. Don't care. Token. Don't care. Something like that. Is that okay?
Yeah.
This program to the first 3 is like that. Okay. And of course we can define numbers, but here it doesn't define number. It just treating other symbol as don't care.
But if you're compiling code, you want those brackets and things like that, right?
Yeah, yes. You want it. But so that duo may be more complicated. It's not just like this.
Oh, okay. You just change
this one just showing you that
expression.
It count the ID and the pass the every other letter.
Right.
Okay. That's the first 3. What's first 3 do? First 4. First 4, every change line you increase the line counter and you increase the character by 1. So this one is a counting of the character and counting of the line. So you have a tab, all these white spaces. So non-words increase. And number of character will be increased by the white length. That means the pattern length. So that is the number of character being increased by the string. Your match pattern. So if you have extra spaces, they will still increase the number of characters by the number of characters that you have. Okay. But the non-word letter will be increased by 1. Okay. Number of characters will increase by 1. And then the number of character you will increase for every character that you have. Okay. So let's run this program before we come back to this rule. Okay.
So there's an advantage to counting lines and counting words and things like that.
Yeah, that's the purpose of doing this, okay? So right here, let's actually create another one called Python2.py, okay, as an example. So here still A equals 1, 2, 3, okay, and then B equals 4, 5, 6, okay, and then A does sort, and then B does sort, and then print A comma B, okay, whatever. This is just a program. I rendered it right, okay. And then let's go back to here. Let me change the CD up. CD flexible for. Now I do Python 2.py. The result still redirected to A.text. Okay, done, right? Done. Let's look at this one. 57, 14, and 4. Okay. So there is print out 3 number. At least 3 number as a number of character, number of word, and number of line. So number of line. Wait, it's only 4. Actually, it should be 5. Okay. So the line counter, I think something wrong. Okay. Line counter, I think something wrong. It should be 5 line instead of 4 line. Okay, and then let's look at the number of the words. Okay. So there are 14 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, it's still not correct. 1, 2, 3, 4, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15. It's still one short. Okay, I'm not sure why this one actually keep counting the wrong way. Actually, the result is one short of the number of character and number of word. And number of character is 57. I don't have time to count it, but I think it counts, but for some reason they started from 0 or something. Okay, so there is one short of the result that we are expecting. Okay, I have to check the program here. Okay, something wrong, but that's the purpose. Okay, that's the purpose for counting the number. Is that okay? That's the purpose of doing this. So that's this next number 4. Let's look at the next number 5. Okay. So next number 5, it actually would detect digit and letters, and you will count the ID with digit and letters. Okay, this one is actually coming with definition of, okay, previous one, we do not have this variable. And right now the variable being put into the Luo here. Is that okay? And then still counting the number of identifier, but it's a modified version compared to the first 3. Okay, but the purpose is the same. So let's run this one now. Okay, let me do this. Let me actually open.
Oh, is that?
What?
Is that set up like your syntax diagram where you get a letter and you get a letter or a digit?
That is a letter or digit, yeah. It actually set up a syntax so that you will detect letter or digit, yes. Okay, this Python 2, I actually go into here, okay, put into here. So there's A.text, B.text, these are some results. We don't work on it. Let's look at this one. I fit in Python 2 to it, okay. So first, Python 2.py. This time I will do it direct to C.text because AB has been used. So let me redirect to C. So C file, it has 9 IDs. 9 IDs, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. Okay. So basically, they are line ID. They are line ID because here, this one we do have later is defined with is A to D or A to D. Okay. That's later. So digit is 0 to 9. Okay. So let's try another one. Let's try IDs that P1. Okay, whatever. Right. Okay. So here, let's try this one. Here, let me try A, B, C. Okay. A, B, C. A, B, C, B, 1, 2, 3. Okay. 3A, 2B, 3C. Okay. A, B, C, 1, 2, 3. 1, A, B, C. A, 1, C, 2. Okay. Whatever this one is my ID2, the PY. Okay. Let's save this one. And then let's go back to run it. Principle 5. Python, I'm sorry, it's actually ID to the PY to D the text. Okay. So let's look at D the text. Number of ID is 9. Okay. Let's look at ID to the PY. So here, there are 9 IDs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, so that's what principle 5 is doing. So let's try principle 6 word. So this one actually more complicated now. Okay, there is a file called Declaration of Independence. Okay, it's declare that text. And then word.l. This one actually would there's including word.h, and you detect letters, punctuation mark, and digit. So basically, let me see this one. Okay. Here, let's actually do this. Let me pull it a little bit back, okay? So you detect word, okay? If it's later plus, you detect words, and then you detect different kind of words, something plus with digit, that's a word 3. So different kind of words, okay? So these are different words. So this showing you different kind of the token type. They are word 1, word 2, word 3, word 4. And then space. Okay. So this is the new word that's set up. So this type is word 1. This type is word 2. This type is word 3. This is word 4. And then there's a space. Okay. These are the definition for the dual. And we are going to feed in. We are going to feed in. Okay. We are going to feed in the Declaration of Independence. There are some wrong file. Wrong file is actually will token the text. You put the declare the text, and then you will feed it into there, and you will generate a file called token the text. Okay. And you can also run this one. So I compile several versions, and then actually run different data. So let's look at the token the text. Okay. So token the text is the token that being generated. So you actually token now every character, every data, every word in the declared independence. Is that okay? Mm-hmm. It token now every single one. The programs. So basically, we do run 3. We do run 3. Run 3 is a big file. I'm sorry. Okay, round three. So on round three, you detect different tokens and then print now. Okay. Is that okay? It's showing you what type of token. So it's word one. Okay. Here we have a lot of word one and then text. Okay. Let's see the other type of words. Okay, that's how this program works. Okay. Is that okay? So basically, you want to write a, so what we try to discuss right here is that whatever tokenizer you want to design, you can use this Flex to generate your code. And then you can use that main program to run it. Okay, that's the purpose. You can automatically generate the okay, generate it. But here we actually are talking about C version. If you like the Python version, it's called pre.
Python version you can run on Mac.
Yes, it's a Python version. Python doesn't need the executable code. Is that okay? What I want to say is that, okay, whatever we introduce, because it's original version of the C language, but the Python version is right here. Is that okay?
Okay.
And Python version is don't need the executable code. It actually is a Python version. It always can be compiled in Python format. Okay? And you specify your calculator, tokens, regular expression type. Okay? So we will introduce this one later, but at this moment, I just introduced the so-called C version. Is that okay?
Mm-hmm.
But we do have this, you can study this one. Okay, later, I think later chapter we will go to here. Okay. Anyway, we finish the lexical analyzer. Okay. And basically, your main program will get the input from the YY-Lex. Your input will be tokenized one by one using YY-Lex. This is the source code. Your program passing to your main program, it will be tokenized one by one. Is that okay? Based on your, the YY text is pointing to your string, the token you have. YY length is how long it is. YY line number tell you which line it is. Is that okay? So basically, the interface between your lexical analyzer and your program is using the variables and functions available that you define in your program. Okay, so that's what it is. Okay, so here we finished all of these. So now, here we do finish all the first introduction for Flex. Okay. But one thing we haven't discussed is the regular expression. Okay. We do know if you prepare the regular expression, you are able to generate the so-called lexical analyzer. But before you are able to do that, you need to learn regular expression. And before you learn regular expression, you need to know this one called extended back-null form. So that extended back-null form is regular expression's sibling. Your input passing through the lexical analyzer will be 3 tokens, number, plus sign, and number. And you will be building a parsing tree to such a parsing tree. Okay, that's the purpose. And then you need to know about the so-called extended back-null form. This one is same power as regular expression, but you need to learn what is sequence, what is choice, what is option, what is repetition. So similar, choice is vertical bar, option is set operation. Repetition, you do curly brace and then add in the mark. Okay. You're like that. So basically, back normal form, this means the revelation is option set is repetition. Okay. Okay, so anyway, let me make it short. This is the IEEE standard for the Becker extended Becker normal form. Okay. And then your regular expression can be written in BNF, expanded BNF or syntax diagram. Okay, these three things can be used to do that. Okay. Okay, next one we look at the regular expression. So regular expression is the core that very important because we are going to use the regular expression in our design. So there's a dot, there's a set, there's an inclusive set. Okay, something like that. We already introduced it. A concatenation or 1, 0 or no 1, 0 or more, 1 or more. Okay, whatever. This actually is regular expression. Okay, let's actually go to, and you can also use the escape sequence. This one is very powerful. If you say \d, that means digit. Capital D means not digit. Okay, not digit. Any symbol but not digit. Capital lowercase s means white space later. \s, capital S means just not white space. Okay. So this rule we need to remember. These are very powerful to replace this. Okay. Okay, there are some other rules. So let's actually go to this rule we'll compare later. Let's go to problem 1. Okay. Problem 1, write in a regular expression so that your string of July 4, JUL4, July 4th, JUL 4th, July 4th, July 4th, and July 4th can be matched. Okay. So this one, you want to do this one. So let's analyze it. You do have JUL at the beginning for everyone. Okay. You do have JUL before any single one. So JUL has no problem. It actually is first one you go. You follow by a option Y, right? So you have JUL4, JULY4, JUL4, JULY4. Okay, so basically it will follow by a optional Y coming back. Is that okay? And the next one you have, you can have 4 or 4s. Right? And this 4 will followed by a optional TH. So that's the syntax we have. That's the syntax diagram. So before you write a regular expression, you write your syntax diagram. Then the next one, you convert is a syntax SDD, syntax diagram, into your regular expression. Okay. So let's see, that's actually is like that. And then solution 1, you will write something like this. Okay. There is a space between them. So there's a space. I forget it's a space. So July 4th, these 4s can be this or this. Okay. Okay, so this is the syntax diagram. Okay. Something like this. Okay. And then you write your regular expression in here. It's regular expression you set up. So basically you try to match it in Python program. Is that okay? Any question? So you develop a syntax diagram, then you code it into here. So go into here, you have the leading, leading JUL, right? There's an option. You can follow by force or Y, followed by the force or the force, right? Is that okay? So this one will represent the syntax diagram on the next page. Is that okay? Okay, anyway. So second problem, write a regular expression pattern that match the string to represent time on 12-hour clock. Okay, so basically you do have one number and then periods and then some number and AM PM. So basically at the very end you have an AM or PM, right? That's the tail you can write first. And in the middle here, you do have 0 to 59. Okay, so basically it should be a 0 to 5, followed by 0 to 9. Is that okay? And then here you have a colon. Okay. And then here you do have 0, 2, 3, 4, up to 9. Okay. Or you have 1 may follow by nothing, or 0 or 1 or 2. 2 is impossible, up to 11. Okay, so this will be the syntax diagram. It's okay? Okay, let's keep this page. Go to the next one. It will show you the result that I showed sometime before. So basically you have 0 to 9, but no 1. Okay, because 1 may be followed by 0 or 1 or no time. Okay, so this one tell you is 0, 1, 2, up to 10 and 11. It is written in this way. Okay, so the hour, okay, and then followed by the colon, and then followed by the minutes. The minutes is 0, 0 to 59. Is that okay? Hello, is that okay?
That's okay.
Yeah, that's okay.
And then this diagram being written in here. And this program is a Python program, so you have different test pattern, and then you use the test pattern to match with the regular expression. Is that okay? If matched, you print it, okay? Is that okay? Okay. Okay, this is the second problem. Okay, so basically, what I want to say is that you need to learn the so-called regular expression. Then you try to practice yourself with regular expression and trying to write the syntax diagram and then putting them into the regular expression to try to apply the pattern. If this one works, go back to, if this really works, go back to your first and type, and yeah, then you can experiment different pattern and then generate a lexical analyzer for you. Is that okay? You definitely need to learn the regular expression first before you can use the lexical analyzer. Okay? Is that okay? And there are problem 3, problem 4, problem 5, several different problems for phone number, for integer, for all kind of problems, okay? These are practice problems you can try out yourself, okay? Let's see what time it is now. Okay, so there are different type of problem in the slides you can try out. You can try out by yourself means that you draw your syntax diagram and then you kind of write your own Python program to match it as well, okay? And if you are good at doing this, your regular expression will be good enough. Then you can go back to use the regular expression to write the lexical analyzer, okay? That's the steps, okay? Right here, I don't have that much time to go through the low detail to build a lexical analyzer, but I just show you the version, okay? The regular expression a lot of information. My slides is very good, okay? So you can learn the regular expression there. And let's jump a little bit further away, okay? And then you can look at the Python Lex and Yex, okay? That's what we really want you to do, is you really can integrate your regular expression idea with the lexical analyzer. You will generate a lex.py and yex.py, okay? So you need to install it. Install it, you just do pip install please, okay? You install it, okay? And then you can use a calculator language as an example. So Lex would have dealing with the calculator, okay? So it actually tokenized like this, and each token being determined by the syntax ID or equals or numbers. That's the syntax units, okay? That's the purpose of lexical analyzer. Okay, and you will associate the token with the token type, okay? Token type, token type, okay? And then this is the example, token type, token regular expression. So if the input matching the token regular expression, you will determine to be the token type, okay? So if you match minus sign, it will be a minus token, okay? If you match the time sign, it is a time token, okay? Left parenthesis, right parenthesis, okay? Okay, so this is the specification, and then there's a program to determine whether it's a number or not, okay? New line or not, okay? And then you just call the lexical.lex, and you build a lexical analyzer, okay? So based on the rule, you kind of test it, okay? So this one is a string, okay? Your data is a string. So basically, you be in a string of this 3 plus 4 times 10 plus minus 20 times 2. And then this is your data being put into a lexical analyzer. And then you create tokens one by one, okay? Create token one by one. And you print the tokens one by one. And you print out a token like this. Lexical token number 321 plus, okay, 21, okay? So basically the first token is 3. 3, okay? So 3 plus 4 times 10 plus minus 20 times 2. These are the tokens. Okay, forget about this 3, 2, okay? 2, 1. And then this is the token type, okay? And I think these are the line number or token number, okay? I think these are line number. Is that okay? It's a line number and token number. Character location, okay? Is that okay?
Yeah, so in the Lex token, it's the first element of the second. No,
Actually, I think this one is line 1. Right here, you do have this one is line 1. This is line 2. Line 2, character 1, character 3, something like that. Character 5, maybe. They are space, okay? I think after tokenization, they tell you the line number and the token location. Okay? Is that okay? That's the output. So basically running through this pre, okay, you'll get that, okay. And I talk about pre because I want you to use this version in Python, okay. You automatically generate the tokenizer. Okay, so basically in here, I do have the input calculator.py, okay, and then output and something like that. So basically, I also can build a parser with it, okay. I also can build a parser with it, and then I'll get the parser result as well, okay. And then you can build your own language converter with pre, okay. Is that okay?
Yeah.
Check this small calculator version. So this chapter basically tell you how to generate a compiler automatically. So try some simple example. You will know the whole process. Okay. Any other question? Okay. If not, we are up to here today. Okay. Any other question? Any question on a homework or project can be asked. Okay, I'll handle it. No?
I still owe you 2 things.
Yeah. So if you need code, let me know. Okay, send email. I'll send some code or slides to you. Okay.
No, I think I'm okay figuring it out. It's just the time.
Yeah. So I think that's it for today. Okay. The video you can check 2017. There's a separate video talking about the Bison and Press. Okay, you can check the video there. And also the code is downloadable from the internet as well. So if you don't find it, let me know. I can give the kind of code that if I have. Okay. Okay. Thank you. Bye now. Okay. See you next week. Okay. Bye bye.
Thanks. Bye.
Bye bye.